Hey there, Taysir here. Back in 2020, we made a video trying to answer the question, which 3D software should you use? We got over 100,000 views on that video, and so now it's about 2025, and we thought we'll make another video trying to answer or re-answer that very same question. So let's talk about that. Before we get started, I want to tell you about this spectrum we made up to try and explain the positioning of different 3D softwares. And in that spectrum, you have two ends. One end is artistic or abstract, and the other end is parametric. And there are different softwares that are scattered around this spectrum. In the abstract side, you're looking for softwares or 3D softwares that are used to create art. You can think of it as, yes, the art pieces that some artists make, but also when you play a video game, you see those 3D artifacts in there, like a rock or a mountain or a garbage or a trash can or a tree or a car. Those artifacts, 3D artifacts, are really artistic on the artistic side because all we care about is how they look. So that's one side of the spectrum, and there are multiple softwares that are in that side. And then there is the other side of the spectrum, which is the parametric softwares. And those are the softwares that are being used by engineers and designers to manufacture actual artifacts that we use around us. So instead of that rock in a video game, if you think about your phone or the pen that you use or the tables and chairs and everything around you, a lot of those were actually designed first in a parametric software, and they fall into the parametric side of the spectrum. And in this video, we will focus on that engineering design side, which is the parametric side. So that's one thing to keep in mind as you are watching this video. Now, talking about those parametric softwares, I'm going to explain different levels of them, and hopefully we can use those different levels to sort of create a framework to help us look and think about those different softwares. And so in this framework, I'm just gonna do low to high in terms of capabilities and use case scenarios. And in each level, we're gonna stop and talk about the common softwares in there and what can you expect from them. And we cannot explain all softwares out there because there's tons and tons. And I'm only trying to squeeze this in 10 minutes or hopefully less. So in the lower end, you get a software like Autodesk Tinkercad. And that's a free software to use. It's very similar to the 3D builder that you get in your Windows machines nowadays. Those are based on just using simple shapes that you mix them together, and then you can create more complicated shapes. Tinkercad is a very common software that is being used to teach kids how to 3D model and how to think about 3D modeling. And so it's very common software for that type of level. However, in this video, we're going to focus on professional use for companies and enterprises. And Tinkercad sometimes make the cut there because if you are really just trying to do something really, really, really simple, then you might be able to manage with Tinkercad. So it's not 100% professional, or at least not what most people would consider as such, but sometimes it can do the job. So that's Tinkercad. Now, moving on to a next software in that spectrum, you get one like FreeCAD, right? There's software called FreeCAD, and this one is actually a free parametric software. It's free for personal use and for commercial use. And so you can check it out if you're just trying to play around, if you're trying to have your first step and you don't want to invest in any other software. 3D CAD or FreeCAD is a good way or a good place to start. And FreeCAD is actually quite capable. You can do simple engines, you can do a pump of some sort, you can do things for your home applications, or you can do simple mechanical stuff for production as well. And it's free. So if you don't mind a what many people would refer to as an outdated or not the best user interface, um, maybe not a very rich number of features, then FreeCAD could be a really good place to go. And it is quite capable for a lot of people if you are patient enough to learn the software. If we go one level up, we get a software like Fusion 360. Fusion 360 is from Autodesk, and it is, I believe, one of their newest additions to their different software packages. And Fusion 360 got famous or have some fame for being really user friendly with good, simple user interface and quite simple to use for many people, at least to get started with. Um, a lot of people also report it's relatively easy to use to model organic shapes. You're looking at maybe like bottles shape, computer mouse shapes, some sort of products around like the back of a chair or the or the wallet or the box of a pair of glasses, etc., etc., etc. But also does pretty good job and mechanical designs as well. So Fusion 360 is new. It's relatively affordable, and it is very, very popular for people who are getting started with 3D modeling. It's popular with makers as well for some reason. Maybe because it is relatively available. It is cloud based. And so if you are to use Fusion 360, you will need a connection to the internet. Of course, for being a newish software, at least compared to some of the others we're going to talk about, it means probably whoever was behind it had a chance to build something from ground up to be easy to use, but it also does not have that legacy behind it, at least for enterprises and business applications. Now, if we go one level up, we can go to a software like Rhino 3D. And Rhino 3D was relatively difficult for me to put in the spectrum because Rhino 3D is sort of all over. It's being used a lot for organic shapes. It can be used for structures. It's used for jewelry. It's kind of Jack-ish of all trade type of software, and it has its own club of users that are kind of relatively more separate to the other softwares we're going to talk about. They're very famous for their Grasshopper plugin, and Grasshopper allows you to sort of put in some programming within your modeling to generate a sort of generative design shapes or applications. So Rhino 3D is a little bit the price of it is actually quite affordable as well. And they also do have one on payment for licenses, at least for now, which means you can pay once and you own the softwares forever, which is really cool because now people just go into, or companies go into those subscription models more and more. Moving on, one level above Rhino 3D, you get softwares like SolidWorks, Creo from PTC, and Inventor from Autodesk as well. And those softwares are really the main bulk, at least when it comes to usage for professional or what's called professional enterprise applications. You're looking at people who deal with manufacturing, basically. So if you do something that, or a company does something that ends up towards manufacturing, statistically, those are the three softwares that are being used the most, number wise. Of these, SolidWorks is the most used of them. There are competitor softwares, or at least you can think of them that way. And so, whichever you can do in one software, you can very, very likely do on the other ones as well. And those are ridiculously capable. I mean, you can design a full functioning car, a full functioning big machines, pumps and compressors, and so on, within one package. If your machine or if your computer can actually handle them, then you can do them right there. And they are sort of the oldish bracket of softwares as well. And so the legacy behind them is quite old, and since they have existed for a very long time. As I mentioned, SolidWorks, between the three, SolidWorks is the most used in the world in the professional cycle, at least in the professional cycle, which gives it an advantage of resources. And so if you're getting stuck, if you're getting need help with something, it's usually easier to find that help in SolidWorks compared to the other softwares, just because the user base is much bigger. It also gives it a little bit of advantage when you're dealing with manufacturers, which is something I found from our experience as well here, is if you're looking at manufacturers and you send files to manufacturers and so on, a lot of manufacturers might actually have, was a good possibility of them having SolidWorks accessible to them, which makes it just a tiny bit easier to communicate and do business. And so this is the bulk, the biggest brackets, at least in terms of number of users. Those softwares are relatively more expensive than, of course, Rhino, Fusion 360. I would throw a ballpark out there, and I would say you're looking at 2,000 plus per year for this type of bracket. And of course, the more packages you add to your design, to your thing, for example, if you want to add in simulation packages or other packages that can help in the design process, you would be paying more money. So they are a bit pricey. Now, if you go one level up, you get other types of softwares or another bracket that includes softwares like Siemens NX and CATIA from Dassault System. And those softwares have a reputation of being catering to really heavy applications. You're looking at aviation, for example. Like a lot of aviation companies will use those type of softwares because they're capable enough to handle a full aircraft, for example. So if you are in those type of applications, you might consider those type of softwares. Those are also, the price points of those are a bit more expensive. I would ballpark it at $7,000 per year per user. So that's the type of pricing you're looking at there. And so that's pretty much it for the traditional softwares that you might have heard of. Now, there are softwares that are more specific to really just one application. For example, you had Autodesk Revit, which is really focuses on architectural applications. So if you're into architecture, you might look into that. For example, there's another software called M4 Plant, which focuses on piping applications. So if you're into piping, you might just consider that. And there are probably others as well that are more and more specific to really niche applications. Now it's 2025, and with that, we also have to talk about a new breed of applications because now those are getting more mature and capable as well. And those are the cloud native applications. And there are two big softwares or two big, providers with those. You got, of course, Onshape from PTC. They're the same ones who do Creo. And those Onshape is a cloud native application. And I would say Onshape has been a growing star for the last few years in terms of people starting to use it. And Dassault System, which is also the company behind SolidWorks and CATIA, also started to have other cloud packages in their 3D platform that they're building. And and in those, you have softwares like XDesign and XShape. Those are also cloud native applications. Now, cloud native applications are ones that you can use without needing to invest in hardware, which is a little bit different than cloud based. So Fusion 360 is cloud based, but cloud native is just a browser. And those are make it quite easy to collaborate with other people because you can think of it as Google Docs for 3D design. So if you're looking into something cloud native, you can look into Onshape, or you can look into the softwares like XShape and XDesign that are part of the 3D experience platform from Dassault Systems. And there is at least for some of those companies like Dassault Systems, because they have computer softwares that you download like SolidWorks, and then they have cloud native softwares like XShape and XDesign. They're trying to create some sort of integration between those elements. And so if that's something you would be interested in, you might also consider that type of applications that would be merging desktop-based downloadable applications and web cloud native applications in a sort of a hybrid thing. So that's pretty much it in terms of the different softwares and how you can think about them. Now comes the important question, of course, which of those softwares should you actually start using, or should you invest in learning? And the answer for this question is, of course, it depends. It really depends on what you are and what you're looking for and the applications you're trying to apply. Now, if you are, because we're talking on the professional level for this video, a lot of times the choice will really comes down to which industry are you looking into and which geographical location you're based on or you're looking into working at. And you can do some research there. You might end up finding that, certain application, certain location, a lot of companies use a specific software. Then that becomes an easy choice because then you just use that software. If you are already working for a company, and that company provides licenses for specific software, then your choice is quite easy. You just learn that software. If you're a student and the university have a license for a specific software, then that might also make it an easy choice. You just learn that particular software. However, if you have the choice of different softwares and you're looking into learning something, then you can consider the financial restraints as well. So if you're quite tight in terms of finances, you can go with free softwares like FreeCAD. I believe Onshape also have a free thing, and some other softwares as well have free things that you can play with. If you can invest a little bit of money, then SolidWorks might be a safe-ish option. You can look into their maker license, which is quite affordable. I believe it's 50 US per year in terms of as a subscription, or other softwares as well might have a maker version if you're looking into that. But SolidWorks is the widest in terms of, or the most used software in the professional level at least. And so it might be a good choice to just start with if you are starting from scratch. And once you learn one software, it becomes really easy to learn other softwares as well, because parametric design softwares kind of work on the same principles and they're quite similar in terms of how they function. And so if you learn one and then you had to learn others because the company requires it or so, then it becomes really easy for you to transition and start learning other softwares. So really the best one to start with is the one you have access to. You can have a choice. SolidWorks can be a little bit safe-ish choice just because it's of how widely used it is. We at TforDesign and myself, we use SolidWorks because we kind of had access to the software early on, and then we just continue used it or are continuing to use it. And of course, it does satisfy all our needs perfectly and makes it easier to communicate with manufacturers and so on. And so that's what we use. And if you're trying to learn a software like SolidWorks, you can actually join us. We've been teaching SolidWorks for 10 years almost now, for a decade, and we've been lucky to have over 100,000 students from all over the world. And you can check out our resources, which I'm going to link in the description. We have core packages to get started from nothing all the way to the professional level, with hopefully price brackets that would fit your situation. And of course, if you're looking into books, we have a book publication with Bucket Publishing, and we have a book coming up called Learn SolidWorks 2025. That's going to be the 3rd edition. It's already on pre-order on Amazon. I'm going to link it in the description as well if books are your thing. And that's pretty much it. I hope this video is able to clarify or give you a better idea of how to look into 3D softwares, at least on the parametric side. We couldn't cover all of them, of course. If there are other softwares that we did not mention and you think should be mentioned and empathize or being empathized on, let us know. Mention them in the comments below, and we can get the conversation going from there. Other than that, that's it for me, and I'll see you in the next video.